Hello again, our most valued student. My name is Confident. Welcome to our part 2 of our lesson on cast diagram, which is under the topic of trigonometry. And as I said, this is good for those who are doing their grade 11, grade 12, or their mathematics N3 or N4. Now, just to also encourage you guys, if you are watching this through our YouTube channel, I'll encourage you to subscribe to our channel, or you can actually press the like button below so that you can be notified every time we post some new videos. This will be your study partner with you as you are doing your studies. It will be good for you to subscribe so that every time there's a new video, you'll be notified of that video. And also you can share this channel with your friends and colleagues if also you are benefiting from it. Now, if I can move on again, as I said, I've done part 1 of this lesson. You need to grab hold of part 1 where I drew this cast diagram and explained what it is all about. Now, in part 2 of this lesson, I'm moving further to say, let us look at the first part is negative angles. Negative angles. Now, when you talk about negative angles and using the cast diagram, for example, let me use the trig ratios. We have got cos, negative theta. We have sine, negative theta, and we have tan, negative theta. So these are negative angles that I'm referring to. So now, whenever you are dealing with negative angles, the first thing you need to understand is when you go in the negative direction, it means you are now opposing what is common. Remember, we said the direction of trig is anti-clockwise. As you can see that arrow, it's anti-clockwise. So now, when you are moving in this is positive direction. When you are moving in the negative direction, you actually oppose the flow, or you oppose what is common. So this is the negative theta that you're finding. So that's where here you get negative theta. So negative theta is found in the fourth quadrant. Remember that negative theta, it is found in the fourth quadrant. So when you're talking about the fourth quadrant, remember only cos C, remember all students take chemistry, so only C is positive there, which means from what we did with our cast diagram, you can see that only cos is positive, sine is negative, and tan is negative. So now when you reduce that, so cos minus theta, because cos is positive, you are going to get cos theta. And then sine negative theta, we said it was negative in that fourth quadrant, so it's negative sine theta. Tan minus theta is negative tan theta. So this is the first part of the reduction rules that you need to remember. For example, let's look at if I'm given cos minus 40, it will be positive cos 40. But if I'm given sine minus 60, it will be negative sine 60. And if I'm given, for example, tan minus 45, this will be negative tan 45. So that is what I mean when I say the negative angles in that case. You can also test it with a calculator to say, if I say cos negative 40, you see that it will give me, don't worry with the number, but look at the sign. You see the sign is positive. What about sine negative 60? It is giving me a negative answer, as well as tan negative 45 is also giving me a negative answer. The reason you're getting it, as I told you, is you are landing in the fourth quadrant, and in the fourth quadrant only cos is positive. So that is the first part that I wanted you to note. And now sometimes they give you a question like this one. Just look at this. If I say to you, I want you to simplify, let me just choose a simpler example for you. For example, sine negative 300. Let's say I wanted to simplify that. So there are two steps that you are going to go through, if not more than two. The first thing you have to identify is that negative sign, to ask yourself which quadrant does the negative sign represent, and you remind yourself that the negative sign means I'm landing on the fourth quadrant, and in the fourth quadrant sign is negative. So which means when you reduce this, it will become negative sine theta, and that is what we are having. From sine negative theta, it's negative sine theta. So but our theta in this case is what? Is 300. So you're going to have negative sine 300. That is the first part. But now you see that 300 is not smaller than 90. Remember, reduction rules says you must reduce things to a point that they are less than 90 degrees. In other words, they must all be in quadrant number 1, which we call it acute. Acute means they must be less than 90 degrees but greater than 0 degrees. So that is the main reason why we are reducing. So they are between, in other words, your angle must be between, in this case, 0 and 90 degrees. That is what we mean when we are saying do your reduction rules in that case. So don't forget that. So when you look at 300 here, you can see that 300 is bigger than 90. So let us reduce negative sine 300. What does it become? You ask yourself again, where do I find 300? You find that again 300 is in this particular quadrant, which is the fourth quadrant. So now you need then to identify the reduction rule of the fourth quadrant, and this is the reduction rule of the fourth quadrant, which is 360 minus theta. So what you're going to have here will be negative sine, don't leave the first negative sign, which is 360 minus theta. But now you know your theta there, whereby you find it by subtracting 360 minus 300. Remember, to get your theta, you subtract those two numbers, it will give you 60, meaning if you subtract 60 from 360, you get back to 300. So this is 300 in a way. 360 minus 60 is as same as 300. Now when you move on, you then say the next part is you're going to say minus, you put a bracket, you ask yourself, when you are reducing, what is sine in this particular quadrant? You'll discover that sine in this particular quadrant is negative. So you'll have the second negative now, which means it will be minus sine 60. So you've got two negatives. That's what I wanted you to take note of. You have the first negative of that, actually the first negative of that, meaning you're in the fourth quadrant, and the second negative of that, meaning you're in the fourth quadrant. So the two negatives, when they neutralize each other, it becomes a positive, and your answer, it becomes sine 60. So which means sine negative 300 will reduce to positive sine 60, and you can simply check it through the calculator here. It can prove that whatever, for example, to say sine negative 300, say equal to, you see the answer is positive root 3 over 2. Then you say sine 60, you see the answer is also positive root 3 over 2. So this is the first part of the reduction rule. Now, having done the negative angles, let us now look at cofunctions. Now, cofunctions are also important. Remember, we've been focusing on 180 minus theta, 180 plus theta, and 360 minus theta. Now, I want us to focus on 90 minus theta as well as 90 plus theta. So that is what I want us to focus on. So that is what we mean when we talk about the cofunctions. So here we're looking at two of them. We're looking at 90 minus theta as well as 90 plus theta. So for now, we're going to limit ourselves on two trig ratios. We're going to focus on cos theta as well as sine theta. We're not going to focus on tan, so the cofunctions only will focus on cos and sine theta. Please don't use these cofunctions to tan. Let me play around with you just to notice something. If I say to you cos 60 is equal to sine 30, I'm going to test it for you. If I say cos 45 is equal to sine 45, if I say cos 10 is equal to sine 80, if I say choose any number, you can choose any number. If I say cos 1 is equal to sine 89, we can quickly test these numbers so that you can see that what I was saying is correct. It's not like I crammed these, but you'll see why I was getting that. Look, cos 60 is half, then sine 30. See that it's also a half. Cos 45 is root 2 over 2. Sine 45 is root 2 over 2. Cos 10 is equal to 0.984, and then cos 10 is sine 80. Remember, it's 0.984. Sine 80, 0.984. Cos 1, 0.99984, and then sine 89, 0.99984. Now the question is, what was I using? Is it because I crammed these? No. Look at something that is common here. If I take 60 plus 30, if I take 45 plus 45, if I take 10 plus 80, if I take 1 plus 89, there is one number that I'm getting. It all adds up to 90 degrees. So 60 plus 30 is 90, 45 plus 45 is 90, 10 plus 80 is 90, and 1 plus 89 is 90. So as long as it is going to add up to 90, the two are equal. Now, why is it called cofunctions? I start with cos, I end with sine. I start with cos, I end with sine. They are opposite of each other, cos and sine, but the angles also between cos and sine, they're adding up to 90 degrees. So what actually am I doing here? Let me further write it like this. If I say to you, remember I said cos 60 was equal to sine 30. 60 plus 30, remember, was 90. So if I say to you cos, where do I find 60? 60 is in the first quadrant, and in the first quadrant is 90 minus theta. So if I come here and say cos 90 minus theta, which angle must I subtract from 90 to get 60? It is 30 degrees. So if I say cos 90 minus 30, so 90 minus 30 is this 60 degrees, right? So cos 90 minus 30, remember we said this was sine 30. Now look at what the cofunctions, what is happening here. So the 30 degrees is now, that I started with, is the 30 degrees that is now appearing on the other side. So which means cos 90 minus theta, when I'm concluding, cos 90 minus theta. Now you don't write cos. From cos, the cofunction is sine, but now it is sine theta in that case. So you're going to include that theta there. That is the most important part. The cofunction of cos is sine. Now where there was theta, you reduced it. Remember, it's 90 minus theta, so you write it as sine theta. That is the first part, which means what is sine 90 minus theta is equal to, so from sine, the cofunction, remember, is cos. Now this theta is the one that you're going to write there as cos theta. So sine 90 minus theta is equal to cos theta. From sine to cos, 90 minus is theta. Now let's use a few examples in that case. If I say to you, for example, I'm giving you cos 15 as a cofunction, you're going to say cos 15 is equal to sine. Actually, before sine, you're going to say cos 15 is equal to cos 90 minus, you ask yourself which number must I subtract from 90 for me to get 15. So you just say 90 minus 15, it will give you 75. So it's cos 90 minus 75. Then now you're going to change from cos into sine. Remember the cofunction, this is same as sine that particular angle, which is sine 75. So cos 15 is equal to sine 75. Remember, 15 and 75 will give you 90 degrees. Having done that, let us look now at the cofunction of 90 plus. So to look at that, how does it work? Similarly to what we're doing here, using cos and sine, if I have, for example, cos 60 is equal to, now since I'm in the second quadrant, actually let me use 120 because now we are dealing with the second quadrant. Let me use 120 to say in the second quadrant. Let me use an example of 120 degrees. Suppose I've got cos 120 degrees. Why? Because 120 is in the second quadrant, right? So with that, I'm going to have in here cos 90 plus, I ask myself what number must I add to 90 to get 120, and I think the number there that I'm getting must be 30 degrees. So it's 120 minus 90, subtract the two numbers, it will give you that number. So it's 30 degrees that I need to add. So if I say, in this case, cos 120 is equal to cos 90 plus 30. You agree with me? But now, look at this one. If I say cos 120 degrees is equal to, the next question I must ask myself is, what is cos in this quadrant? Now, cos is negative in quadrant number 2. So you are going to use the sign of cos, because 120 says cos is negative. So you're going to say here minus, I'm just emphasizing that, minus, and after that, remember the cofunction from cos, it becomes sine because you're dealing with 90, and then the angle that you're going to use is that reduction angle, which becomes sine 30. So cos 120 is equal to minus sine 30. Now test it again. What you're going to have, if you use a calculator and you say cos 120 is giving me negative half, and then you say sine 30, actually it's not sine 30, it's negative sine 30 from my thing is negative half. Do you see that this works together? Choose another example. If I'm given, for example, cos let's say 145 as an example is equal to cos 90 plus, now I subtract 145 from 90, so 145 minus 90, it will give me that angle, which is 55 degrees. So it's cos 55 degrees. So which means cos 90 plus 55 degrees is equal to, then I ask myself, what is cos 90 plus 55 degrees? Remember, I'm starting with cos, I'm going to end with the cofunction, which is sine. Now the 55 degrees will be the angle that I'm going to use here, which means cos 90 plus 55 is equal to sine 55. So remember that it is how you reduce that. What does this mean? It means we have a reduction rule here, which says if I'm given cos 90 plus theta, like 90 plus 55 is equal to sine, actually there is a negative sign, I forgot to put that negative. Remember, in the second quadrant, like I did here, there is a negative sign there, so it's equal to negative sine theta. This is very important. Don't forget the sign. The sign of the second quadrant cos is negative. So you use the sign of cos. So it is equal to negative sine theta. Now, since we've dealt with cos, what about if I do sine? Let me use a similar example to say sine 120 degrees is equal to sine 90 degrees plus 30. Remember, we used 120 previously with cos. At the top here, it was 90 plus 30. So now I'm using for sine to see where does it lead us. Now, if I write this one and say sine 90 degrees plus 30 degrees is equal to, now you use the same thing from sine, the cofunction of sine is cos, and I ask myself, what is sine in quadrant number 2? Sine is positive, so which means there is no change in sign when I'm dealing with sine. So it's going to be sine, then the angle that I'm going to use there is that angle which is sine 30 degrees. I mean cos 30 degrees. If I use the calculator also, it will give me, if I say sine, just to conclude, therefore, here it means sine 120 degrees is equal to cos 30. So just check it with the calculator. I'll say sin 120 degrees is equal to root 3 over 2. Cos 30 is equal to root 3 over 2. I think you can see that the reduction rules are working in simplifying this. Therefore, we can also conclude another reduction rule to say sine 90 plus theta is equal to, from sine we go to cos theta. I hope you see that. So now, conclusion, what do we have in conclusion? We can conclude, just want to write this clearly. So we can conclude here a few things. Conclude and say cos minus theta is equal to, it's in the fourth quadrant, remember, it's cos theta. Sine minus theta is in the fourth quadrant, negative sine theta. And tan minus theta is also in the fourth quadrant, is negative tan theta. Again, we have got reduction rules, which says sine 90 minus theta is in the first quadrant. From sine, you go to cos theta. And cos 90 minus theta, this is in the first quadrant. From cos, you go to sine theta. That's the first part. And then the second part, you have got sine 90 plus theta. Now, what is sine 90 plus theta, which is the second quadrant? Remember, in the second quadrant, according to our cast diagram, sine is positive. So this becomes cos theta. But cos 90 minus theta, and cos is negative in the quadrant, it becomes negative sine theta. So these are the core functions that are very important for you to know, as well as the negative angles that are very important to know. Now, since I've managed to show you from the first lesson, I managed to show you the reduction rules of 360 minus, 180 plus, 180 minus, as well as now I've shown you the 90 plus and 90 minus, as well as negative angles. In the next lesson that we're going to do, I'm going to be showing you now questions that you expect concerning these reduction rules. Join me again in the next lesson. Thank you.